Moving on to the next one, we have yet another keynote presentation on the smart way to design your software-defined vehicle by Mr. Basavaraj Patil, Head Embedded Software Vector Informatic India Private Limited. He has over 27 years of experience and is an electronics and communication engineer who brings a wealth of expertise to the automotive domain. Can we all give him a huge round of applause, everyone? Come on.
Good afternoon, everyone. I am Basavaraj Patil. So I am based out of Bangalore, and I am heading the embedded product line at Vector. Yeah, sorry, your tea break is cancelled because of some delays, but I will try to make it fast. Yeah, let me take the other side stage. Yeah, thanks to Naveen and Srinivas to give a good overview on the whole SDV ecosystem as well as the hardware platform. Now it makes my presentation more easy, where Vector is focused more on enabling the SDV journey by giving the right platform as well as the software tools for development and testing. Yeah, before beginning, let me give a brief overview on Vector. Many of you know, but for those who don't know about Vector, we are around 4,500 employees spanned across the globe in 76 countries. Last year, we just reached 1 billion sales, and we are around 14 countries located and 33 locations and 14 countries. Even in India, we have 2 locations, Bangalore, Pune. So we want to enable software development in the vehicle, and we provide the necessary software tools to develop the systems. For example, we cover the complete V cycle of the software development, right from system engineering with pre-vision, defining the whole vehicle, software architecture, design, everything, as well as the embedded software, low-level drivers compatible to AutoSAR, adaptive AutoSAR, and now the SDV platforms we are giving. We are also focused on testing, right from unit testing, hill testing, integration testing, and the complete test hub. We are also focused on diagnostics and flashing, providing various tools for authoring diagnostics as well as testing. We also focused on calibration and measurement by providing various tools and measurement and data management in the PC as well as in the cloud. So we're also a small unit focusing on the consultancy as well. Yeah, now beginning with, so definition of SDV. Yeah, various people have various definitions. I don't want to really define, but general, as the name says, yeah, continuously updated software defines the feature of the vehicle. Yeah, it is not easy to tell only the software updates because most of the vehicle features are also dependent on the hardware. So there is also focus on hardware, software, code definition, as well as the levels of SDV, which is going to come in the next coming years, 5 to 6. But focusing on SDV, what does it mean? Yeah, we see a lot of penetration. Yeah, most of this automotive system development was pure hardware, then it becomes software influenced. Many software was developed on microcontroller, ARTOS. Now the mobile technology, yeah, cloud technologies, many things are coming into the vehicle. Yeah, what does it mean? Does it mean smartphone on vehicles? I can update the application, even that is possible. Even now Android is on the vehicle, I can update from the Android App Store, the new applications and update. But is that enough for an SDV? What is behind? Yeah, it is much more complex. Yeah, as you know, automotive, a lot of regulations, a lot of standards, safety, security, real-time response, a lot of mechatronic systems, electrification, many new technologies are coming up. How do I cope with all this? So I have to make these new technologies from smartphone, cloud, etc. compatible to the vehicle standards. We try to build a combined ecosystem so that both the technologies, legacy automotive plus as well as the new cloud and mobile technology coexist. So that is where our journey is. So I would present some of the key enablers and solutions for making the SDV easy. So the first and foremost is the E architecture. Yeah, Naveen already presented the different evolution, right from function oriented to domain oriented and now the centralized. So why this architecture? We see a lot of evolving technologies, many, even AI is coming into the vehicle. So simple microcontroller is not enough. We need microprocessor, SoCs to have such big computing, and hence the HPCs. If you see the legacy control issues like powertrain, battery, chassis, now they are moved to the I/O system, maybe control I/O system. There are some complex I/O like LiDAR, radar, camera, where you need some intelligence and processing. Or there can be simple sensor I/Os, or light, rain sensor, heat sensor, or window movement, seat lift, many things in the ecosystem. And most of these domain controllers have now become zonals. It's no more domain, but then zone, front, left, middle, different OEMs have different ways to control the different zones. But the focus now, evolution is the HPCs, yeah, which are based on SoCs, Majorly because of the mixed criticality, multiple HPCs are there. It's not one SOC, it is not easy to hold. The combination of FASIL, QM and different levels. Typically we have seen that OEMs choose at least 3 HPCs, one ADAS, IVI and some generic for the vehicle application. And as well, cloud is one of the part. It's not separable. Because a lot of vehicle applications as well as connectivity, accessing the vehicle, we have to do from the cloud backend. Be it software update, data collection, software debugging while vehicle is running, diagnostics over cloud and many more things. Yeah. What we see here is the introduction of the purple line, which is service oriented, so that with the service oriented communication, I have a downloadable application or a middleware platform in HPC so that I can install new and new apps. So thanks to the mobile technology that we are bringing that inside the vehicle. And the remaining things, zonal and to the sensor activator is signal oriented, like CAN, LIN, FlexRay. These technologies still continue. In the most advanced SDVs, maybe this will get replaced with service oriented communication where we can have a pluggable hardware with the hardware software ecosystem. Yeah, with this as the basis, let's see how to manage this architecture. Is it enough? Yeah, to have some HPCs, some zonals and other sensor IOs. Of course, it is hard for OEMs to migrate, but managing this is also equally complex. Yeah, how to do that? Yeah, we call that as shift north. Yeah, abstracting hardware and mechatronics ecosystem so that we have a platform for new application innovations in the HPCs and zonals, and service-oriented architecture between the HPC, zonal, cloud, but still consolidate safety, security, and all the aspects. And in the mechatronics system, better to use off-the-shelf COT system instead of OEM-specific thing. Let us bring some COT software so that OEMs can optimize the cost. But what is shift north? Yeah, this might be a new term many would have heard, but it is nothing but how do you manage the software and distribute it? Yeah, more downloadable app where the software you think is not stable, or you want to bring in new software in future, or some applications which need more computing, or the software which are more hardware agnostic. You can say pure software, you start moving them up, be it zonal if it is more real time, if it is less real time, put it in the HPCs, or if it is a backend computing, which doesn't affect the real driving of the vehicle, then put them in the cloud. Yeah. When it is more safety relevant, yeah, or homologation relevant, real-time capabilities, or variant dependencies, multiple hardware and for variants, start putting them down. I don't want to bring them variant dependencies in HPCs. I want to have a generic HPC hardware, scalable, and also future ready with more resource. But variant dependent hardwares, I will try to bring more in the lower layers. And yeah, customers can have more opinions on how to divide and manage this whole E architecture. The next big thing is the scalable base layer. As you have seen, there are so many issues, HPC, zonal, that itself has their own operating system. It's not just OS, we call it as a platform or a base layer. Like you have Windows operating system. Also in the vehicle, you have heard many terms. Yeah, MBOS, Stella Brain, many things. And the thing behind that is a scalable base layer and a software factory together. They call it as a OS so that we have a platform and a development kit to develop new applications and download. Yeah. Vector has a definition. It is not just our vision. It can be different at different OEMs and different ECUs. But what we see is a common software base layer or a platform which can be used across multiple ECUs, be it HPCs, zonal, control ECU, IO ECU. Yeah, if you see this legacy, control ECU plus zonals, they still continue to use Microsoft Classic because of the real-time nature. Yeah, they can have microcontroller and HSM for cybersecurity reasons. And we try to come up with a new solution, Microsoft IO, which can be off-the-shelf solution, not compliant to AutoSAR or anything, but which has a low footprint and low cost, low memory, is a new solution from us. And the base layer for HPC, yeah, it can contain both Microsoft Classic for a safety zone, the HSM for cybersecurity, and the switch to manage the switched Ethernet, as well as a combination of various domains. As you see, in an HPC has such a big computing platform, so OEMs are combining multiple domains, multiple applications into one HPC so that they optimize the hardware and cost. So there can be a hypervisor running multiple middleware, say IVI, for example, Android or ADAS middleware like NVIDIA. There can be Microsoft Adaptive for a vehicle application, and there can be different open source software. Yeah, vector is fine. We have our some core components developed, but we are also fit in something is ready, off the shelf available, which is standard. Then we try to plug in and then try to create a common base layer. But the key thing is to make this application development easy, irrespective of the common base layer. There is a vision to have a middleware agnostic application, but it is not yet ready. But we try to bring in some kind of application framework I have in next slide. But it's also important that we have a cloud platform. Yeah, for example, this Microsoft Connect we have is a connecting partner to the cloud to enable some of the features like OTA, data collection, SOVD, and vehicle application execution framework as well. Yeah, we have seen that RTE, yeah, this abstracts the whole base layer. So it enables the hardware independent application development as well as the platform abstraction. With adaptive AutoSAR, we have seen it enables some of the communication. It gives some of the libraries or daemons for the applications to use for vehicle communication, diagnostics, persistency, security, etc. But there are many more open source middlewares. For example, it could be IO abstraction, GUI, graphics drivers, and it could be new protocols like DDS, protobuf, and many new things. There is no common abstraction for the application developers in the adaptive domain. So we are coming up with something called as application framework. Yeah, this abstracts and give a interface for the application development. It abstracts the whole platform as well as it enables development in different bindings like C++, Rust, and many more languages can be used for the HPC ecosystem. And if you see, there are lot middlewares, as I told. But then that middleware is not the vehicle communication, this thing. There are some IP, DOIP, and many other protocols over Ethernet, which are the legacy vehicle standard. So Microsoft Adaptive can act as a bridge for connecting the different heterogeneous middlewares like Android, etc., to communicate with the vehicles easily, keeping the vehicle aspects. It is not just implementing some IP. There are many open source, some IP drivers you can use, but then they fail to achieve additional features, for example, safety, security, and many more things. So all those protocols are built and inbuilt within our Microsoft Adaptive. So it can be used only for communication. It need not be the whole platform. So there are multiple use of Adaptive. So what we are seeing, yeah, is the complete development ecosystem is changing. It is no more OEM, Tier 1, Tier 2, Tier 3. So with the development of HPCs, so one Tier 1 is not able to develop the complete HPC. Even OEM is not able to manage. So mainly the HPC and zonals are managed and owned by OEM nowadays because of the IP, and they want to build in their new innovations in-house. But then what is happening now? We see there is a collaboration between all. Even the service provider, Tier 2s are also approaching OEM, and there we need a collaborative development across all these partners. Yeah, there are more than 10s and 50s of different varieties of companies who are involved in one HPC development, I can say, right from hardware, software, everything. But how these people come together to develop? We have seen in Tier 1s, there is some kind of development hub, servers, CI/CD to speed up things, but then that things need to be made accessible to all these partners. So we need some kind of a development hub managed by OEM primarily, because OEM owns the complete development of HPCs and zonals, what we have seen, or they can offshore it to some of the partners. They can be a software platform partner or the vehicle integration partner. Even they can own such software factory hubs. Yeah, Vector also enables our tools to execute in such cloud platforms like AWS, Azure, etc. So we can provide all our base layer software components. It can from other application suppliers. There can be in-house application developers at OEM. We also give advisory service how to develop such software hubs. Yeah, and we can also enable them. We can also have examples where we implement such software factory for some of the OEMs and enable them in the deployment into the vehicle as well as the backend storage. But to do this, yeah, we need a well-defined workflow, right from system design, architecture, development until deployment, covering the complete big loop, covering all the technologies, tools, and a defined workflow. Yeah, we need exchange formats, workflow, everything standardized so that this becomes easy. Yeah, we need to have a system design workflow where the artifacts can be extracted automatically and can be an input for the application development as a base layer development, as a platform. So both can go independent in parallel. I should be able to develop an application independent of the hardware and the platform. As well as I should be able to develop a platform for the specific ECU independently and then integrate them together and test. The same, we should be able to do a virtual integration of the individual domains, ECU, and the vehicle. So that's why this gray box I covered under software factory has nothing but the shift left or virtualization. The next slide I will cover something how that infrastructure looks like. And then comes the software deployment. How I deploy and test in the vehicle as well as deploy the applications post the vehicle is on the road. The new app installation, subscription-based installation. This whole infrastructure and workflow, we should have a defined set and workflow across all these suppliers. Yeah, this is one example how a cloud-based infrastructure look like. Yeah, you can have this AWS, and then different development and testing will run as a pipeline in a containerized environment. We also have something called Canoi for software, vVirtual Target, SILKit for virtually testing individual applications as well as the ECUs and connect them. Multiple ECUs can be connected by SILKit for a virtual vehicle testing. And very, very most important is from vehicle project to software platform driven development. Yeah, this is a key aspect for optimizing the cost. What we have seen is many OEMs, will have multiple platforms for vehicle. So whenever they want to launch a new vehicle, new variant, then they decide, okay, which ECU, which variant of that ECU, and then try to make a vehicle platform as well as a test strategy for that vehicle platform. So repeating that for each vehicle adds additional cost. So why don't we can have a software platform driven approach? That means I can have a common software platform which can be used across the HPCs, not just one HPC. And then whenever there is a new vehicle release, then I take whatever is the latest. And I can also backport that software because the platform is already ready for even the older vehicles. So that I enable new features introduction to the older vehicle as well. So this software platform driven approach will optimize a lot of cost at the OEM development. Yeah, as a summary, Vector enables SDV development by providing the necessary base layer with the software factory and the advisory and supporting services. We have passed through this journey, implemented this at multiple OEM, and can bring our best practices and experience into the table. Thank you. And we have our SDV demo in the stall. Please find time later, go and visit. We have the complete demonstration of the SDV. Right from individual application development, platform development, complete compilation and testing on the cloud as well as deployment into the vehicle to demonstrate a feature change for a front light control. Please visit our stall to view the demo. Thank you.